Hey guys, welcome to the shop. Now, this week we're going to be starting where we left off last week on our K&T gearbox. We're going to remove this shaft, and I've got a piece of stock in the lathe that I may use to make this shaft. I don't know, we'll see. But let me bring you in closer. We'll tear this shaft. We'll take this shaft out of this thing and get a plan to make a new one. Alright, so I've been looking at this thing and I noticed that this shift fork looks like it's a little tweaked, maybe a little bent off to the side, and it's probably bent where it goes through this pin here. That'd be my guess. So I don't know, I may run into some issues there. We'll see. I want to get, how did they even bend those pins? Yeah, man, they sandwich this little pin up in there, and this thing's just finger tight. They didn't, probably for alignment, they didn't want to tighten this thing down. I don't know if we'll run into issues there or not, but probably will. Years of, probably not years, but probably a lot of time of people fiddling with this thing and trying to use it with it being broke. Wow, that's in there. And don't break off. They probably, forced on that a whole lot with it not being in line and caused it to, probably bend over a little bit. So there's that pin. And I'm going to have a wrench. This nut off. Getting that tapered pin out may be tough, and I don't have the reamer for that pin either, so that may be an issue. At least I don't think I do. How is that supposed to come off of there? This has to come off, and I noticed there's a pin here they have packed up in here. Just a little pin, I think we can rotate it. And it's got a little threaded, I think you can, it's got 1/4 threads in it, so I'm going to put a long bolt in it and see if I can pull it out. Yep, that's it. That's why they threaded it, so you could pull it out. Pretty neat. Now, hopefully, this whole unit, step out of my way, will slide out, and it does. And what was that? Oh, a pin, a key. Oh, that goes in this shaft. Okay, no problem. Alright, so there's our brake. That's pretty neat, ain't it? Man, if that wore out, you'd be in trouble. Because you ain't going to go buy that, I wouldn't think. So that is our brake material, clutching material, braking material. It's still real thick. Got a little wear ring on it, but not much. And this is just machined in a matching taper, just machined in the casting. So pretty neat design. So I'm going to pin all this stuff back together the way it comes apart. That way it's easy to remember. And then we will pull out our detent for our clutch shaft. Pretty neat. Oh wow, oh, that just slides right out. Yeah, now I can get that out of the way. This thing isn't under too much spring pressure. Not too bad. Our safety glasses and put a rag over that so it don't flop up and hit us right in the face. Okay, just a spring. Just a spring and a triangular shaped top. And I guess all that is, yeah, there it is. So now we can, that both keeps this straight because it has a slot, and it slides on this little roller here that cams it in and out. So it's pretty neat. Let's get this out of here and look at it. I'm going to drag that through that casting with those burrs on it. So I'm going to grab a file and knock those off first. There we go. Right, so it's a little more complicated than I originally thought as far as our shaft there. And if I'm not mistaken, that looks like that's been welded before. And I believe it's been repaired at one time. It's probably not the first time it's failed. Yeah, it's definitely been welded. A poor welding job also. Let me get you a little closer shot at this thing. Let's see, that looks like a liquid almost. Looks like JB Weld to be honest, but it's not. And then I'm seeing you know, these here. That's somebody's tried to weld this and it's been ground on. And looks like when they recut this or machined it, they had a sharp shoulder there where it separated. Just a poor repair is what it looks like to me. This is where they had no bonding at all with their weld penetration. This is just my opinion. It looks like it got into here, almost nothing here. I got to digging in my box and actually found the tool that fits it. So I actually have a tool to cut that. Couldn't believe I had that. So I'm gonna have to dress it up though. It's dull, but there you go. At least I don't have to start from scratch. So we'll probably cut this on the shaper. Alright, so here's the top of the fork and the bottom. And this is a tapered pin, so we're gonna have to drive it from the bottom out. It's got like a bronze washer here also. Hopefully this thing will come out. Not any much problems. Probably should put it in a vise, but I'll first try this. Yeah, that was easy enough. Popped right out. Wow. There we go. Other end of our shaft. I need to make sure I don't have that. Yeah, it's definitely been welded up. Make sure I don't have that reamer. I may, but I don't think I do. Okay, so as best as I can tell from the measurements here, this is a number 6 tapered pin. And I do not have a number 6 tapered pin reamer that I'll have to have in order to you know, drill our new, or ream our new shaft to match this. Now they use these because they're self-holding and you know, they actually do a pretty good job. You know, they usually don't come loose once you drive them in, and sometimes they'll peen over the ends to make sure, and then they're really tough to get out if they do that. This one actually came out easy. So I'll have to come up with a number 6 tapered reamer. Now I have all the small ones other than a 7. Right here, you can see they go down to, I don't have the smallest size, but they actually go down to really, small tapered pins. And the only large tapered pin reamer I have is a number 4. And then there is a number 3 tapered pin. So they just vary a slight amount from one end to the other, and they wedge themselves in the hole. And they hold whatever you're trying to stick together pretty well. So I have to come up with a tapered pin reamer. Alright, so here's the shaft I'm considering using. I haven't, decided for sure yet if I want to take a chance on this, but what this is a shaft out of a large electric motor. Now, I can't tell you exactly what this is, but they don't use normally cheap stuff in the shafting of electric motors. But I don't really like the finish. I've just made a couple rough passes on it. It's about the perfect size to make the shaft out of. It's already got accurate centers in the ends and everything, so it's really almost perfect as far as its size. That's why I'm considering using it. But I'm not getting the finish that I really want. I've tried several things. I've tried a shear tool, I've tried different geometry, carbide inserts, sharp high-speed steel, and this is about as good as I can get with a real positive cutting carbide insert. It's not bad. I mean, it's perfectly acceptable and should be fine, but I don't know. I'll probably end up making 2 of these shafts. This will probably be my practice piece, and then I'll probably buy a good piece of 4140 or something like that, maybe a piece of stress proof. I'm just not for sure yet, but this, I have it on hand and I can start making something, so that's what I'm doing with this. Here's a little closer look at the finish. I don't know how much you can tell there, but this shafting is fairly hard, so it's tearing more than cutting really, and this was a ground shaft to begin with, but nonetheless I'm going to move forward with it because, like I said, I want the practice. And I'm measuring this end. Now this is between centers, so every time I run between centers on this lathe I have to adjust the tailstock depending on where the tailstock sets on the lathe bed. So we are 1.381 back here. And let's see where we're at up here. And we are 1.3825. So about 1/1000 larger here than it is here. So I have to adjust my tailstock. I'll show you that real quick. I mean, a lot of people make adjusting a tailstock, or they think it's a lot harder than it is. And I'll show you how I do mine real quick for something like this. And it's real quick and real easy. Alright, so like I said, we're smaller here than we are here. So I want to move this portion of the bar, the tailstock end, away from the cutter. That way it removes less material here than it does up here. This point up here is not moving, so we can adjust our adjustments here on the tailstock. I'm going to use a 1/10 indicator because really for a small adjustment like 1/1000, you need some resolution. So that's what I'm going to do. Set it up on my part about where I took my measurements. Come in and zero it. Now I'm zero, so I'm going to loosen my tailstock. I have to unclamp it, and then I will have to loosen this nut here. That will allow the tailstock to move over a little, and I'm going to split the difference that I'm off. I was off 1/1000, so I'm going to move 3/4, 7.5 in the away from the cutter position. That will make sure that I don't cut, any extra off this end than this end from what I have right now. Alright, so if you watch this indicator in the corner of your screen, this is my 1/10 indicator, and I'm just going to zero it, try to Now I want to move this, this is smaller than this, so I want to move this into the cutter. No, away from the cutter. I was right the first time. 3/4 of a thousandth, basically. Now I'm not trying to get this perfect, even though that's, I say that, but I'm talking about thousandths. But I have to unloosen my tailstock from the bed, and then you'll see it'll move. It should move a little. Now, if I clamp it back, it goes back to 0. So I'm going to take my measurement from that point, because when I clamp it, it'll move. Re-0. Now I need my wrench. So I want to loosen this side. That will allow the tailstock to go away from me. And now I'm going to re-tighten it. So that should put me really close. We're still not going to be perfect. I don't care if this is absolutely perfect, but that's just the way I do it. Alright, so I got a dog here. If you can see that. Got a dog running this. And I've got my dog clamped onto a jaw with a C-clamp. And right now my centers are not crazy tight. Because this part's going to grow. I don't have enough flood coolant ability to keep this thing super cool. So I don't tighten these centers up. You know, see, this is, I'm rotating the center by hand. I mean, it's good and snug. It's not loose at all, because as this part heats up, when I cut it, it'll grow, and it'll, if I'm not careful, it'll push my tailstock out. By the time I get to this end, this will be slightly loose. So I don't start real tight. It'll tighten as I go. As long as it doesn't get loose, I'm good. And this is just my experience on, my equipment with the flood coolant and stuff that I have. So let's get this thing set up and make a few cuts on it and see how accurate the adjustment we just did worked. Let's measure it and see what we got. You can see I got a little piece of copper underneath the screw here, just so I don't, damage the shaft. Alright, let's check this. Let's see what we got. So that is 1.361,235. So 1.36 and a half. Oh wait, 1.3 61 to 3 thousandths and a half, so 63 thousandths and a half. So 1, 3, 61, 2, 3, and probably 4/10. So man, that is close, you know, close as I can measure. This is not the best surface to measure on, but we hit it on the money. And it doesn't always happen like that. I mean, in fact, most of the time you have to do it a couple times to get it within. But that's the way I do it. You know, it gets me pretty close. And let's see that. And even though I was running coolant, it wasn't necessarily to keep my carbide from, you know, eating up, because just taking light cuts, it was to keep the temperature in the shaft down. And I could spin it easily with 2 fingers gripping hard, and now I can't. So it raised the temperature in the shaft grew in length. So, you know, you got to be careful, and if you're always getting loose on your tailstock, chances are, you know, it's just your part's growing and pushing it. Check the center. Just my experience. I'm not a machinist. Yeah. Maybe a couple tenths larger in the center, but that makes sense because it's going to deflect. And it would get worse, I would assume, the heavier the cut you take, depending on your tool geometry and the cutting pressure. So good. I'm going to work this thing down and, you know, hopefully get something usable out of it. I don't know how it's going to cut on the shaper. That's what I'm concerned about. I can always get this finished nice on the lathe if I have to just hand polish it. But I'm not for sure how the gear teeth will cut. We'll see. One more thing I need to mention, because I'll get 7,500 comments on it if I don't. I'm rolling my sleeves up. You know, it's dangerous, it is, but you're not working out in my shop without some warm clothes on. It's like 40 degrees out here. Especially when you're running a dog and stuff, man, this is asking to get pulled in. So I'm cautious and careful. But long sleeves can get you in big trouble if you're careless and get too close to the chuck. I mean, sometimes you can not be careless. Pros get pulled in, but you know, you just got to use your best judgment and be careful. So my word of caution: these things are not toys, and this thing will eat you. Just had to say it. Alright, so we're getting close on the lathe. I just want to check my bar to make sure. See about where I'm at, or where I need to be. Okay, so we're 1.123 and a half. So 1 inch, 123 thousandths and a half. So bet you the bore is a even 1.125, and this is undersized for clearance. Yep, same thing. Let's check the bores just to be sure, and then we'll make our final cuts on the lathe. Alright, going to use our little Starrett bore gauges. These are really nice. Just expand it in the hole there. Make sure you're in the center. Snug it down. And rock it out. And we're right on the money, 1 1/8 inches. That's what I figured. Alright, let's finish cut this thing and get that part done. So I let this thing cool down, took my measurements, and I need to remove about 13 thousandths. That'll give me my major, and then I'll have to work down the shoulder. Not the shoulder, but the smaller portion. And checking the centers to make sure it's still good. I don't want to mess this thing up now. It's turned out really good so far. Harmonic because it's so long. I'm just setting a little weight on it. Just to keep it from vibrating, that's all. I'm not pushing on this, just letting the weight of the bar. It just helps absorb any vibration. Stops that bar from getting harmonic. There we go, it should be it. As far as the major OD anyway. Alright, so the finish is not bad on this thing. It's not perfect. Not bad, acceptable. But I am going to take some 240s where I'm going to start and polish this shaft down a little bit and give it a good sliding surface finish, because this slides back and forth in that housing, and it's not exactly where I'd like it. But we're a few tenths over anyway on our size, but still within perfectly good clearance range. But I'm going to polish it down a little bit, give it a little better finish, and then we'll work our smaller end. Alright, that's about as good a finish as I'm going to get. I mean, it's real smooth. It's just not a mirror finish, but perfectly acceptable for the application. Now, for the beginner guys, this here is just a piece of stock. It's just I didn't want to take the chuck off and stuff in order to put a center in here. I mean, I have it, but it wasn't necessary. I do this quite often. And I'll just take a piece of stock, turn a 60-degree center on it with my compound, and then use the jaws to drive the dog. And that's a good thing about doing center work, is you can just take your part out, check your measurements on the surface plate and put it right back in, and should be just as accurate as it was before. So now all I like to do is turn down the end here, the end that goes through the shift fork. Let's go over the surface plate. I'll show you the tools that I'm going to use, and we'll take a look at the shaft and get our measurements. Alright, so I got the original shaft over here. Got some parallels on the plate to raise it up a bit, so I can use this flat as a reference surface to check and see if my slot here that my spring detent goes into was 90 degrees to my gear teeth, and it is. So that's, another little question solved. I've also got a broken spring. This was up inside of the spring detent, so somehow that spring got broke, so I'll have to replace it. And here's the broken end of the shaft. It measures 873.5 thou. And is around 2 inches long. That's what we're going to cut it anyway. 2 inches long. instead of the sharp corner that they had right up here where it transitions from large to small, we're going to use a radius, and we're going to have about a 3/64 radius. It's just a piece of Lathrop Crusader XL. Now, looking at this shaft, I would say most of the work that was done on this thing was done on a horizontal mill. Just a guess. Like this, so we've got a radius here, a flat that leads into a radius, and I would say that that was done with a large shell mill running across. Then they probably, did the gear teeth, and this is definitely a horizontal mill, big radiused scallop, I guess, in there. I'll probably just use an end mill. It's a 3/8 width slot. I'll probably just do a rectangular slot with an end mill. I wouldn't think it would weaken the shaft doing that, but that's my thoughts. And then we're going to have to address this off-center hole. So you have to come in and use a coaxial indicator on this one, set it up in the mill, and then transfer our new shaft over and drill our hole. That's probably the way I'm going to do it. I'm still not for sure. I'm just, you got to think all this stuff out, and that's what I'm doing. So the bore in our fork happens to be around 879 thousandths. So our original fits just a little loose, so I'm going to go about 1,000th larger on our pin diameter here, just to make it a little tighter fit in the fork. So let's go over to the lathe, let's turn this end piece down and get one step closer to being done. Alright, so we're about ready to cut this. I just blued it up, and here's another good use for the hermaphrodite calipers. It's just rough layout like I'm doing here. I've got plenty of shafting here, excess. So I'm going to cut this just a little long, and we can just come back and cut this to length at a later time. And these are really good. You don't want to always, or you don't want to use your good calipers, electronic calipers or digital or dial calipers to scribe those lines, and that's what these are for. So little Brown and Sharp 835s. We're just gonna do a rough layout here, and that's it. Got a little extra foot here so we can touch on the end of the shaft, come in, and make our line. Guys, wintertime is here. The water's moving pretty heavy right now. We're across the road from my house. Let's see, most of the leaves are gone by now. Amazing what a week's time makes as far as difference. This should be our final cut here. We're looking for 874. Not too bad. Got a decent little radius in the corner. There's better ways we could have done this, but this should work okay. We are 874 and a couple tenths. So I'm just going to take my file and smooth that up a bit. Should be good. Let's get it out of the lathe and take it to the bench. It's a good thing about center work. If it ain't right, just take it, put it right back in. Let's go look at this. Okay, here's our fork, and then we have a washer that goes in between here. But what would have been really nice is a large radius in this, and then a matching large radius in our fork here, and that would have transferred the load onto the larger shaft. Or, you know, this could have been bored out slightly. You could have went larger here. I mean, there's a lot of ways you could go to probably improve this, but you know. Should work. There we go. Now we need to make possibly some test cuts. I don't know if we'll get that far today, but some test cuts. Then there's lots of ways we can do that too, but you know, we'll discuss those at the shaper. Do a test fit in our bores. Just enough room to fit and operate. Very nice. This is a 90 thousandths depth of cut. This is just another piece of stock, just a test piece. I want to try to see a couple different methods on cutting the rack teeth on our shaft, because there is a couple different ways. So I'm going to try a few, see what works best. For me anyway, this setup. So now I'm gonna change tools, and we're just gonna try to plunge straight down, feeding up with the table, just to try and see how it works. All right, this will be my very first attempt to run this cutter. This way will be the most pressure involved way. I'm just gonna run the tool straight in, and I'm gonna be feeding down with the compound. Zero it. I'm going to feed down about 220 thousandths. Call that a 0. Leading down about 24 or 5 thousandths per stroke. Pretty good. It looks actually really good. I didn't feel like that took hardly any pressure, really. Try another one. That's pretty easy. Well guys, I think that's it for part 1. Part 2 should be out now, but if it's not, it'll be out later on this afternoon. Go look for it, but it may be later. It depends on how far I get on the editing. So, thanks for watching guys, I really appreciate it. If you haven't, make sure to subscribe to the channel by clicking on my little guy up here and hit the bell for notifications. Thanks to all my subscribers, viewers, and patrons. You guys are awesome. And I'll see you next time.